Now let's look at the definition of local and global variables. All the variables that we define inside the function file are local. Okay, these include the input and output arguments and also any other variables that are assigned within the function file. This means that the variables are defined and recognized only inside the function file. It is different with a script file. Okay, so the variables that we define inside the function is stored somewhere inside the function. They are not stored in the workspace. Okay, you can look at the examples that I have shown earlier. So the variables, okay, are then used in the calculations inside the function file. So it means that if you have defined a variable, let's say you have defined a variable of a name b in function file, you can also use the similar variable name of b. Okay, you can also define similar name of b on command window or other script files. Okay, so these two variables, okay, MATLAB will never be confused about these two variables, although they have the same name in the main script file or other functions. However, it is possible to make a variable common. Okay, which means that the variable defined in function will also be recognized in function files and also in the workspace too. Okay, you can do that by declaring the variable global both in the function file. Okay, do it after you do the definition line and in the script file. Okay, this is how you can make the variable global. Just type global followed by the variable name. Okay, let's look at this example. Maybe we'll open our MATLAB. Okay, so here I'm going to define a new function. Okay, you click the plus icon here, click function, and then here we define function output, and then the function name would be g, and then the input is 2, which is x, comma, and y. Here we describe the summary of the function. And then a description about the input variable. And here are the function body that we need to calculate the output variable. And then you save the function. Make sure you save it inside the current directory. Do not change the auto populate file name. Okay, by default it should match the function name. Just save it. So I already saved it here. Yes, so now I'm going to demonstrate what are the difference between a local and global variables. So as you can see inside the function here, we have defined x, y, a, and output. We have defined 4 variables. So all the variables that we define inside this function are local to the g function only. So when we want to execute the function, okay, call the function name and then enter the input argument inside the parentheses, and then you hit enter, you will get this a and s variable. Okay, observe the workspace. The a and s variable is created on the workspace. Okay, but not the a, x, y, and output variable. Okay, so that is the definition of a local variable. And then we are going to use this equation to calculate our output result. So here you can see that result require information, okay, of g value here. So to do that, we supply the value of g by defining that inside this function file. Okay, and then you save the function, and then let's try call that function. Then you will get the answer. But what if I forget to supply information of g? Okay, receive your function, and then maybe I can try to define the value of g through command window. Okay, and then call that function again. So what happened is you'll get this error using g. Okay, it means that the function have not enough information to produce the output. Okay, it has a missing g information. So that's why whatever that we define inside the function can only be accessed by function. Okay, function cannot access any variable that we define on command window or other script files, and also the command window cannot access the variable that were defined inside the function. Okay, so that what it means that the variable defined inside functions are local. But we can make this g variable global. Okay, so we can do that. Look at here. Okay, you have to modify your distance function, okay, by typing this global g. So now I'm replacing the lowercase g with the capital case G, and then receive the file, the function file, and then go to command window, define global variable inside command window also. Okay, define this global g, and then you define the variable inside command window, and then you can try to call the function, and then you will get the answer. So this approach allows you to change the value of g without the need to redefine the distance function or providing the value of g as an input argument to the distance function. Okay, so by now you already know that there are two types of functions provided by MATLAB. Okay, the first one is built-in, and the code is not accessible to us, and the second type consists of groups of functions of M files. Okay, this is what we have done recently. You can use the type function to see the code inside the function M files. Okay, the type function will inform you that the function is a built-in or print out to the command window all of the lines in the M file with that name. Okay, so you can use this type command followed by, let's say, any function name. Okay, you can try type scene. If it is a built-in function, it will tell, okay, that it is a built-in function. Okay, you can try a few example of built-in function, but let's try type star. Okay, so what happened it will display all the codes inside the function file. Okay, now let's try to solve this problem, exercise 1. So here is an expression to calculate the velocity of water using the difference between the total and static pressure. Okay, so PT is the total pressure, PS is the static pressure, V is the velocity of water. So you have to create a script that will ask the user to enter values for total and static pressure. Let total pressure equals to 1000, static pressure 500. Write a function named fluid velocity that will calculate the fluid velocity, and then use formatted print statement to display the results. Okay, round value down to the nearest whole number. Okay, so you are going to create a new, two M file here. One file for the function file, second file is for the script file. Script file is what we use to solve the problem. Okay, so first create new function. So the function output is v. This is the function name. Input arguments, we have two here. Insert the summary. And then type the equation, okay, that you need to calculate the output. 1.016 multiply with square root pt minus ps, and then save this file. Okay, use the auto populate file name, save, and then now clear workspace and command window. Next, create a new script. Okay, this is the script file to solve exercise 1. Okay, so the total pressure will the value of the input for total pressure, we will get it from input command. Okay, so pt string, enter the total pressure, ps, enter the static pressure, velocity is, we assign the output, okay, from the function file. So velocity will be obtained from the function. Okay, this is where fluid underscore velocity is the function name. So you will use whatever value that is supplied from the input command here. Sorry, I forgot to insert the word input. Okay, next we are going to use the fprintf command to display the results. Okay, so we need to round the value to the nearest whole number. Okay, so fprintf, the fluid velocity is, okay, this is the placeholder, d is for whole integer, and then \n to create a new line. Okay, so next input for the, okay, the second input for fprintf command is the floor. Is we use floor when we want to round it to the nearest integer, and then a velocity. Okay, close the bracket. Okay, and then we can run this section. Okay, so enter total pressure, let's say 100. 50. V is equal to 7.18. Okay, so alternatively, okay, you can assign a value for that PT and PS. Okay, so alternatively you can also assign value here. Let's say I assign 1000 and then assign PS to be 500, and then I clear the comma window so that it is easy for us to check the results run section. So you will get the value is 22. Okay, so that's all for the first part of user defined function.